All right. When I last saw you all, we looked at compound interest and continuous interest as some of the application problems that are associated with exponential functions. What we're going to be looking at today, though, is going to be when we're dealing with population growth or decay, radioactive decay, and some other scenarios. And the formula that we're going to use when we're dealing with these is what you have right here. And this is on page 2 of your packet. Now, what you guys will notice is that this formula is actually incredibly similar to this. In fact, it's the same thing, except we use different variables. So in this problem, we have n, this is not, n naught. So that means when the time is 0, that was our initial size or the initial population. Whereas when we were looking at compound interest or continuous interest, the p was representing the principal, which was always the initial investment. Now, the first thing that question number 6 asks us to do is it asks us to find what the initial population was in a scenario in which 6 years ago, 6 years ago, frogs were introduced to an environment. The current population of frogs after those 6 years is 100, and the growth rate is estimated at 42% per year. So the first part of this question asks us, find the initial size. Well, that means that we're looking for n naught. But we know that our growth rate was 42%, and that after 6 years, the population of the frogs is now 100. So when we go to solve for this, we know that we can just divide by e to the 0.42 times 6. Now, in our calculators, when we do this, we are going to get 100. Oh, first thing you're probably going to want to do is you're probably going to want to plug in the e to the 0.42 times 6. Then you can do your 100 divided by that quantity. So we're talking about frogs right now. So when we are talking about frogs, if I have 8.045996, well, I can't have 0.045 technically of a frog, and we have not reached 9 yet. So the initial population was 8 frogs. Now, the next question then asks us, well, what would be the population 5 years from now? So when you guys go to look for that population 5 years from now, there's 2 ways that you guys could go about doing it. And the answer might vary slightly depending on which method you use. Well, we could use the 100 that was given in the original problem, and we could say, okay, if I want to know what the population is 5 years from now, right now I'm at 100, and so it's going to be 100 times e raised to the 0.42 times 5. Now, when we do this, we get approximately 816. Now, the other way that we can look at this is, in our first part, we just estimated that the initial population was 8. And we know our growth rate is 42%, but currently, if we're looking at this problem, 6 years ago, the population was 8, and it wants to know the 5 years from now. So the amount of time that would pass then would be 11. Now, remember, there was some slight rounding that occurred with this 8. So it's to be expected that there's going to be a slight difference here. So we're going to have 8 times e to the 0.42 times 11. And so this time around, we end up with approximately 811 frogs. Now, the question is, well, which one is it, Mrs. Dempsey? Well, I would take either answer as long as it was supported by the word.